Welcome to solverfy.
In this problem, we are trying to find our indicator for each of the following titrations. We know that indicators will have a pH value that is approximated by pKa plus or minus 1. For part A, we are given 0.1 molarity of HCl, which is a strong acid, and 0.1 molars of NaOH, which is a strong base. A titration between a strong acid and a strong base will result in an equivalence point with a pH equals to 7. And by looking at the indicator chart, when our pH is equal to 7, this would give us bromo-thymol blue. In part B, we are given 0.1 molars of HCOOH, which is a weak acid, and 0.1 molars of NaOH, which is a strong base. With a titration between a weak acid and a strong base, we will have an equivalence point of a pH that is greater than 7. So we will need to start by constructing an ice table. Given here is a reaction equation that we will write between the weak acid and strong base. And to keep in mind, at an equivalence point, our number of moles of acid and our number of moles of base is equal to each other. So as we solve for our ice table with the following reaction, our initial number of moles would be the same. We will have 0.1 moles of HCOOH and 0.1 moles of NaOH. On the right side, we will start with an initial moles of 0 because the reaction has not proceeded yet. Next would be our change. Since the limiting reagent is they are both equivalent, we will minus 0.1 moles on both sides, on the left side, and add 0.1 moles on the right side. This will give us a result of 0.1 moles of COOH. Next, we will need to find the molarity of COOH. Because both the acid and the base takes up 1 liter, where HCOOH will be 1 liter and NaOH is another liter, the addition of the two will give us 2 liters in volume. So when we solve for the molarity of COOH, it'll be our number of moles, which is 0.10 moles over 2 liters, which gives us our molarity of 0.050 molarity. Next, we will construct another ice table and solve for our molarity for our OH, where we can eventually find our pH of the titration. This is our equation. we start off with 0.050 molarity of COOH minus. We can disregard our water and we will have 0 on the right side. Then our change would be our unknown, which is X. And then we will have our final results. Next, we would need to use the values of Ka to calculate Kb. Now, our Ka for HCOOH is given below. To calculate for our Kb, we know that the relationship of Ka and Kb is that when you multiply Ka and Kb, we have Kw. Kw is 1.0 times 10 to the negative 14th power. Using this relationship, we can solve for our Kb, which gives us 5.556 times 10 to the negative 11. We will use our Kb value to solve for our OH molarity. Our Kb is equivalent to x squared over 0.050 minus x, given as indicated in the equation, where we have the products over our reactants. As we put in this equation in our calculator, we will solve for our X. Our X is also the concentration of OH minus, which is 1.667 times 10 to the negative 6 molarity. We can calculate our POH, which is negative log of OH minus, which is this value. Next, we can calculate our pH, which is 14 minus our POH, which gives us a pH of 8.22. Now, we know that indicators have a pH value that is approximated by pKa plus or minus 1, and we can locate our chart or picture on our textbook to find out what our indicators are. In this case, our indicators would be the following two: thymol blue or phenolphthalein.